All right, this is the surface area of prisms. So today we're just going to focus in on three basic prism shapes, and we're going to talk about how to find the surface area of each of them. One main difference we need to talk about is two different vocab words. One is a right prism, where it is a very square, rigid, upright, every corner is a right angle prism. And then you have oblique prisms, which are tipped one way or the other. They're not standing up straight. Their corners are not 90 degrees. What's nice to know is that when you go to use the formulas work on they work on both right prisms and oblique prisms. So when we go to look at our formula card, it doesn't matter if your shape is leaning or straight up, you will use the same formula. You just have to look at your base, figure out which picture you're going to use, and then just do that formula. So let's go to our formula card. I'm just going to cover some things up just to help us focus on what we're doing today, which is these three. So we've got triangular prisms, the picture that I just showed you, that leaning kind of triangle. We've got rectangular prisms, and then we are going to do our n-gon prisms. And these are the series of formulas. Okay, so let's just talk about the triangle one first. So in a triangle prism, we have got two triangles as our bases, and then we've got three rectangles, the back left, the back right, and then this front rectangle right here. So the formula has two of the triangles. Triangles are 1/2 base times height, so that's two of the triangles, and I just kind of labeled it like those are your bases, those are your triangles. And then you have the three rectangles that go around this shape. So three rectangles. And I wrote they're probably different, meaning like you're not going to have the same base and height for each one of those rectangles. They're most likely going to be different measures, which is kind of like, it makes this one the most work because you have to find each triangle or each rectangle individually. The overall formula, or kind of the generic formula for a prism, is 2 times, and a capital B means area of, so 2 times the area of the bases, which is the same as this, and then perimeter times height. So perimeter kind of abbreviates needing to do all three of the triangles. If you figure out the perimeter and then just times it by height, it does the same thing as these three triangles. So if you like this formula, awesome. It's broken down by every single shape. If you like this formula, the in general formula, you totally can use either one of them. They will get you the same answer either way. Next up, we've got the rectangular prism. Rectangular prisms are made up of 6 sides. You have the front and back, you have the top and bottoms, and you have the left and rights. And each of those pairs are the same. So the top and the bottom will be the same measurements. The left and the right will be the same measurements, and so on. So I have 2 times base and height, 2 times base and height, 2 times, okay. So there are 2 tops and bottoms, there are 2 left and rights, and there are 2 front and backs. And most likely all of those will be different measures as well. Unless you're doing a cube, then they'll all be the same. And the note I wrote down is all sides date once. And I'll tell you what that means, but what it means is you're matching up every pair of sides one time. So every 2 numbers get to go on a date is what I call it. But I'll show you in an example. Again, the generic formula for a prism is 2 times the area of the base. So you would have the bottom as your base, and then you need 2 of those. And then if you do the perimeter of the base times the height, it takes care of the other 2 situations. So kind of pick your formula, stick with that, and keep practicing it the same way each time. Next up, we've got our pentagon or our hexagon or our n-gon shapes. So we need 2 times the area of the base, and the base here, well, this is a pentagon, but it could be anything. So the base is going to be our 1/2 ANS formula that we did in chapter 11, and you need 2 of those. You need the top and the bottom bases. And then to get all of these rectangles going all the way around, we need the number of sides, so 5 rectangles. We need the side length, which is essentially the base, and then you need the height. So that's kind of taking care of all of your rectangles. And then the 2 and the 1/2, they cancel, so you really just end up with ANS. I should have also said that up here. You can cancel these 2. I like to keep it like this because I want you to remember that that has to do with the triangles, that base and height is not a rectangle thing. And I'll kind of explain what that means in a little bit. So, or you could do the generic formula again, which is 2 times the area of the base. So the base is the thing on the bottom. And you'll have 2 of those, one on the bottom, one on the top. And then you have perimeter, so you could do perimeter of the base, and then times the height. Thank you. So let's go try a couple. I have got, the first one says, draw a net and find the surface area of a right rectangular prism. So I'm going to first draw a picture of that. We're going to look at the net of this picture. I'm going to start by just drawing kind of what a cube or what a rectangular prism looks like. So kind of like that type of shape. And then if I peel that apart or unfold it, I would have the bottom of that box. And then I would have the two edges on either side. Then I would have the front edge. And if you kind of think about it, this would be like the spine between the top and the bottom. And then there's my other one. It's kind of like a pizza box if you fold it up. So fold that side up, that one, and then this guy just closes the box. So I have a height of 2, I have a length of 5, and I have a width of 6. And it truly, on a rectangular prism, does not matter where you put these numbers. The answer will come out to be the same either way. So let's just say this is our 6. So all of these verticals are 6. All of the long sides are 5s. And then all of our short sides are 2s. And your job is to find the area, essentially, of each one of these rectangles. And you can find area of a rectangle. You've been doing that for a long time. You have 2 that are the exact same size, 6, 5, 6, 5. You have 2 others that are the same size, 5 and 2, 5 and 2. And then you have 2 that are 6 and 2, 6 and 2. And now I'm going to show you how to use the formula to kind of mimic that. So our surface area formula says that we're going to have 2 times base and height and 2 times base and height. These are all of our different sets of sides. So we have like top and bottom and left and right and front and back. So I'm going to start with top and bottom. So the bottom, if I trace that, is just a 6 and a 5. So the area of this rectangle, so 6 and 5. And I'm just going to draw a line between them. That's what I mean by that. I don't know. I think I'm funny. They're going to date. So these 2 are going out on a date. When I go to make my next match, I can't match up 6 and 5 again because I already did that. So 2, and now if I do left and right, that would be this one and this one. So that's a 5 and 2. So I'm going to draw a line between them because now 5 and 2 have gone out on a date. They've matched up. My last one would be my front and backs, and that would be 6 and 2. So that'll be my last match. And then my job is just to simplify. So 2 times 30, 2 times 10, and 2 times 12. Gives me a total of 104, and our label for this one is centimeters squared. Next up, I've got a triangular prism. And so I just need to find the area of each one of these faces. I have 2 triangles, and that's how that formula starts out. So it says 2 times, and then 1/2 base and height. And remember, this is just of the triangle. This whole section is just the triangle. So just focus on the triangle. You have a 5 and a 12. Those are your height and your base. And then we have to do 3 rectangles. So we have the rectangle on the bottom. I'm going to shade it. Talking about this rectangle. And if I trace that, I would hit the 12 and the 10. So that is my base and my height. Just squeeze this in here. I'm writing too big. And then you got the left side. And that would, if I traced it, would be a 5 and a 10, because that's the same as this one. I'm just going to write this down here so I don't get too far over there. And then the last one I have is actually, it's kind of hard to see now that I've been shading, but it's the ramp part of this triangular prism. So think of that ramp like we'd go up this ramp. So that's my last one. And if I trace one side, it's 10. And if I trace the other side, that is a number I don't know. So we're going to actually do your favorite theorem, Pythagorean's theorem, in order to find it. So that's my hypotenuse. So I have 5 squared plus 12 squared equals, I don't know, hypotenuse squared. So I got 5 squared plus 12 squared, and then I just have to square root that. So I end up with 13. So this hypotenuse right here is 13. That's the other side to my rectangle. I'm going to bubble that because it's not really part of our formula here. So the 2 and the 1/2 can cancel. So I got 5 and 12. I've got 12 and 10. I've got 5 and 10. And I've got 10 and 13. So putting that all together, I've got 60 and 120 and 50 and 130. So 360. This one is also centimeters squared. Next up, we've got one of our n-gon shapes. So I'm just going to follow my formula, and it says we're going to do 2 times 1/2 ANS. So first I need to see if I have the A. So you start from the center and go to the middle of a side. I don't have A anywhere in my picture, so I'm going to skip that. N is number of sides. I can count that, so that's 5. Side length, if I go around the outside, they gave me a side length, so 7.05. And then I have all of the rectangles. So I could do the side length, which is 7.05, number of sides. So I've got 5 times 7.05, and then height, which is 9. Squeeze that in there. The last one we have to find is actually our apothem. So I'm going to draw that triangle right here. I'm going to draw it over there. I can see my 6 is my hypotenuse. And 7.05 is the whole side length, and I just want half of that, just like we were doing last unit. So 7.05 divided in half will give me 3.525. And then we're going to do Pythagorean's theorem on that. So 6 squared is by itself, 3.525, and I'll put an A there so we remember that that is apothem. So 6 squared, and then we'll minus the 3.525 over, and then we square root that answer. So my apothem looks like it's about 4.86, we'll say. Now our job is to type all of that in. As a reminder, the 2 and the 1/2, they'll cancel each other, so I don't really need to do that. I'll do times 5 times 7.05 plus 5 times 7.05 times 9. So it looks like I get about 488.4 feet squared. One last one to do. This one we're actually going to solve for x. So they tell me what the surface area is, and they'd like me to figure out what x is. So I'm going to start with this formula, which on your formula card is the 2 times base and height, the 2 times base and height, and 2 times base and height. This is the one where everybody dates once. So surface area they gave me, 2 times, I'm going to match up my first pair. I'm going to do 8 and 6. I'm going to match up my second pair, 6 and x. I'm going to match up my last pair, 8 and x. So 292. I have 2 times 8 times 6, so I have 96. And then I have 2 times 6, which is 12x, and I have 2 times 8, which is 16x. So I'm going to put my x's together. I'm going to subtract 96 over here. So 292, oops, you can't see it, minus 96 gives me 196. I'm going to put 12 and 16 together to make 28, and then all I have to do is divide. So 196 divided by 28 gives me 7. So that side must have been 7 meters long. And that's your first kind of day, just dabbling in the surface area of prisms. Stick to your formula card, pick out the side lengths that you need, and then just plug it in.